Alright, for this video we are talking mostly about circles, lines, and systems of equations, which means we're going to be starting with tangent lines, secant lines, systems of equations, and solutions, which as you can tell we're going to be going through and filling in some definitions first. Now, I know this year it's on page 206 in your workbook. It may be different each year, just make sure you pay attention. Now, the standard we are talking about mainly today is MM3G1, where we have students will investigate relationships between lines and circles. In particular, we'll be working with equations of tangent lines to circles at a given point and solving systems of equations. And we'll be working on this for the next several videos. So I'm going to go ahead and queue up our video so we can go ahead and get started. All right, first off, we have a tangent line. A tangent line is a line that intersects or touches, could be either way, the way you think about it, touches a circle. And it's going to do it exactly one time. Not two, not three, not four, but one. So here's our circle, right here. And here is our line. And if you look, there is going to be our point, or our point of tangency. And there's only one of them. That's how we know it is a tangent line. So let me erase that, and I'm going to move it out of the way so we can go through, and we're going to talk about secant lines next. They're similar to tangent lines, just a little bit different. Now, a secant line is a line that's going to intersect, not just touch it, it's going to actually intersect and go through it. A circle two times, not three, not four, not one, but two. And so we're going to look at our circle again, and there's our little line. And if you look, we have one point right there, and we have one point right over here. Those are our 2 points where our line intersected. Now, the next definition we need to know for this is about a system. A system is a set of equations, as you would think, that we are going to be asked to try to solve, which also means we're going to be trying to determine the solution. Now, the term solution may be something a little bit new to you, but we're going to determine the solution. Either we're going to do it graphing or we're going to do it algebraically. And I'll show you how to do both. It's just right now we're just trying to get some terms out there. Now, just in case, you will know we're talking about a system when we see this funky little bracket right here. You will see this bracket shaped this way, and you will see two equations over here. That's how you know we're talking about a system. Our last definition for right now is solution. And solution is pretty much a synonym for something you've already done before. It's pretty much any and all points that make an equation or set of equations true. In other terms, it's the answer. It's what you want. And generally, it's where they intersect, or when you're doing algebraically, where you get the numbers. So let me catch up with my writing. Where the graphs intersect. All right. That one is stopped. Let's go on to the next slide here. We're talking about graphing circles now. So let me go ahead and cue up our recording. All right, so first off, it asks us to graph a circle with a center at 0, 0. That's easy. And it wants us to do a radius of 3. So go left, right, up, and down from there, count 3, and then draw your pretty little circle. Remember, it doesn't have to be perfect, but make sure it's something round. That's actually pretty good. All right, now, it wants us to draw a line that does not intersect with the circle. I don't care what you draw there. It doesn't specify. You could draw a straight line out there. You could draw a parabola over here. You could draw a circle, because technically it is still a line. You could even draw a squiggle, as long as it does not touch your circle. Now, it wants to know how many real solutions it's got. So if you think about it, this one never touches your circle. This one never touches. This never touches it at all. And this never touches. So, since the solution is where the graphs are going to intersect or they're going to touch, and these don't touch at all, there are no real solutions here. So no, we're not going to have any real ones. All right. Let's move on to our next page. Now, if you look here, if we talked about something not touching it, we probably got to touch it this time. So, All right, this time we're talking about a circle with a center at 0, 0. So there's our center, and we got a radius of 2. So this is actually kind of small. So do the same deal. Up, down, left, right, go 2, and play connect the dots by drawing your circle. All right, now we want to do this. We want to draw a line that intersects the circle or touches it exactly one time. So I didn't specify how. So I could draw one straight across like that. I could draw one kind of like that. If I really wanted to, I could draw a parabola, but it didn't say. So now it says if the equation of the circle and the equation of the line were solved as a system, how many real solutions would it have? So we're looking for graphically how many times they're going to touch. So if we're talking about the red circle on the top blue line, it only touches one time. If we're talking about the circle on the bottom blue line, it only touches one time. So if you think about it, since these only touch it in one space, it's only got one real solution. And that's it. So let me catch up with my writing here. So just to kind of paraphrase, since they only share one point, there is only one real solution here. Now we're back up here into the questions. So it's asking, is the line tangent to the circle? Well, if you think about it, if it only touches it one time, that's based on one of those definitions we just talked about. Yes, by definition, it is a tangent line. And then it wants to know, the last question, how would we write the equation of the line? Now you got to think back a couple years. We haven't talked about this in a while. We got to do the equation of a line, which is at y equals mx plus b, where m is going to represent your slope, which you can find using that y2 minus y1 over x2 minus x1, or your rise over run, however you want to think about it. And that number on the end is going to be your y-intercept. You've got to keep those in mind for the next couple of days. Otherwise, you're going to be in big trouble. So, all right, we got one more to talk about. Think about it. We went through, we didn't touch the line at all. We touched the line one time. We got to go through, we got to touch the line twice. All right, so it gives us another circle this time. So we have a center at 0, 0 and a radius of 5. So starting at 0, 0, plotting our points, going 5 out to the right, 5 up, 5 left, 5 down, and let's draw our circle. It's pretty decent. I could do better, but now it wants us to draw a line that intersects at exactly 2 points. It didn't say how, just intersecting. So I could go straight across, I could go top to bottom, I could go diagonally. Doesn't say. I could even go through the center if I wanted to. Okay, so now let's figure out about our points. So the top one with our circle has 2 points of intersection. So let's do our vertical line next. We have one here and one here. So that's also 2 points of intersection. And then our diagonal line, we have the point here and the point up here. It also has 2 points of intersection. So basically, we can sum up that a line that intersects the circle at exactly 2 points is going to have 2 real solutions. And then I'm just going to sum it up and write it up over here to the side. That since they intersect 2 times, there are 2 real solutions. All right, and that's it for this video.